Alrighty. Alright. Check if array is sorted and rotated, previously solved. The streak of easies continues. Given an array nums, return true if the array was originally sorted in non-decreasing order, then rotated some number of positions. Otherwise, return false. There may be duplicates. So 3, 4, 5, then 1, 2, then this is true. Rotated twice. Rotated left. Rotated. Guess rotating left or right is still the same. Yeah, rotating right 3 versus left 2. Alright, this is not 1, 3, 4, 2. 1, 2, 3. Very short array. Trying to think whether or not I can do this in log n. Arrays. Can I do this in log n time, or does it have to be log of? Yeah, it has to be of n. I don't think I can do it in log n time because you have to. You're never sure, right? You're never sure. Okay, so the simple way would just be if there's like 2 spots where it's going from high to low, from higher value to lower value, that means, yeah, there just can't be 2 spots. 2 to 1. Oh, wait. It goes high to low. And that has to be the spot where it breaks. And then that low has to be the lowest number in the array, and that high has to be the highest number in the... Okay. So I'll say for I, let's say n is the length of the array. For a in range n, maybe it should be n minus 1, because I'm probably going to compare k to nums at k to nums at k plus 1. I think here I do something like if nums at k is bigger than, are these values unique? There may be duplicates. It has to be strictly bigger. Nums at k plus 1, so that means it's decreasing. Then nums at k must be highest, and nums at k plus 1 must be lowest. Nums at k and k plus 1 must be highest and lowest if rotated. It's necessary but not necessarily sufficient condition. It's necessary for it to be that, but it's not the only thing that's necessary, so it's not sufficient. Okay, so if that's the case, then I guess I keep track of this, right? I guess maybe I can say the low and high are initially infinity, negative infinity, positive infinity, and here now the low is going to be equal to, I don't think this doesn't feel right. I equals nums at k plus 1, I guess. I need to also check if this is the second time that this has occurred. Found breakpoint is indeed false. Okay, so I think if not found break, then do this. But if it's already found another time where this has occurred, then I guess I can just do if found break. Return what, false. Else that. Okay, otherwise it's going in increasing order. And if it's going in increasing order, then that's all good, really. And then at the end, I can say it has to be the low has to be lowest, right? The low has to be lowest. So I think the low has to be lowest if low is greater than the first element in the array. Greater than or equal to? No, this is greater, right? Yeah, if it's greater than... What am I doing here? The low is greater than... greater than the first element. Then that return false. Or I guess the high is bigger than the last. No, bigger than. The high is less than. Gosh, what am I doing? Rotation. If this thing 1 compares to 3, if this one 1, 3, 4, 2. 2 has to be the high, so this 2 needs to compare to this thing. This 5 has to compare to this 2, this 1 compares with this 3. This 1 has to be lower than this 3. And also this 2 has to be less than this thing. Okay, maybe I just need to compare these two, to be honest. Yeah, maybe I just need to compare those two. If nums at 0 is greater than or less than, it has to be greater than normally. So I guess if it's less than nums at the last, then it returns false. Nums is 0. It's correct if it's greater, not correct if it's smaller. Okay, I think that might be it. I guess maybe I don't need to keep track of this because it needs to keep on going too. Needs to keep on going and seeing if there's any other, and verifying that it's increasing order in the other spots. So the first time it does it, so if it's increasing order, it's fine. Maybe I think I prefer it if I do this. If nums at k is less than or equal to nums at k plus 1, this is fine, so continue. And then otherwise I do this statement. If I found the break, then this is the second time, then it's not good. Else, I think I can do an else if here, right? Else if, so if this is the time where I find the break, like the 5 to 1 or the 2 to 1, then the 1 needs to compare with the 3. No, just compare the 3 and the 2. Yeah. Okay, and then just return true for this. I think my logic is not on highest mental ability right now. I think this works though. Oh my god. Oh my lord. This returns true. Oh, whoops, shit. Found break, else. Okay, else. Whoops, I guess this should be else. Because I need to actually set found break to true. Wow. Poor, poor, poor. I guess I should probably do this in reverse order. Okay, let's try that again. Got to use the test case. Okay. Alright, that was far from the easiest easy, for me anyways. Summary. Okay, not sure if I really did the simplest logic with this. But basically, we'll need to iterate over for every kind of consecutive pair of elements, the values in the array, and do some logic on it. Fail conditions for when this array is not some form of sorted rotated array. Sorted sorted rotating array is one if there are two instances of drops, decreases in value between the consecutive value, like 10 to 5 or 3 to 1. And the second one is if it is rotated, the first and last values in the array need to be in kind of non-increasing order. So for instance, let's say it's 3, 4, 5, 1, 2. The 3 has to be bigger than 2. Or 3 has to be at least 3 is greater than or equal to 2. If either of those fail cases occur, return false. If after iterating over all indices, it doesn't return, it doesn't fail return true. All right, time flex is O(n), since it will be necessary to go over all indices of the array to verify that it passes the conditions. And basically this is just going to be O(1), since no extra space is needed